Hey everyone, this is Martin. This is the third video, I think, in the C++ OpenGL FPS Game Engine kind of follow-along video series. So for those of you who might not have seen this, the previous videos, basically what I'm doing is following along on a Udemy course around OpenGL C++ and building a game engine specifically for FPS. And I'm just going over kind of what I've learned a little bit roughly and sharing as I'm following this course, not covering everything because I can't share the entire source code or everything that I'm doing. You know, it belongs to the author of the course. But this is also partly me recapping and just understanding what I've followed along on and just trying to cement it a little in my brain. So anyway, in this video today, I think this is video 3, but we now have physics. So let's play, see where we're up to, show you something new. So FPS controller and box physics as well. So this is quite a big step. I've not done a video in a couple of weeks. I think it's been pretty slow progress just because I've been so busy with work and just life in general. But this is new. So this is like an FPS controller now. So affected by gravity, able to jump. The cursor is no longer on the screen as well. You saw that box fall into the world there as well, and I'm colliding into that box. That's a rigid body dynamic object. The player character is a kinematic object, meaning that it's part of the physics system, but it's controlled via code. It's actually very choppy at the moment, which is a little odd because it should be frame rate independent. These boxes up here are not in the part of the physics system, so you can see I can clip right through these. And the same with the what's this monkey head called now? I've forgotten. But all these models here. But the floor itself is a physics object, and that is it's a static physics object. So it's not affected by the character myself as a kinematic object, and it's not affected by this dynamic box object. However, the kinematic and the dynamic objects are affected by static objects. So 3 kind of physics systems there, or physics types. So dynamic, like the box, kinematic, the character controller here, which is being moved around via code, which is part of the physics system, and then dynamic, static or dynamic, which one I said. Sorry, it's late, my brain isn't working. Anyway, let's just hop into some of the code, and you can see kind of where I've followed along, and hopefully it'll make a little bit of sense to me as well, because honestly this is useful for me to recap and just figure out, okay, I can see where the systems are tied in. So I'm watching the videos as I'm going, I'm typing along with the video afterwards. I'm watching it first and I'm following along and typing, but there's parts of it where it's good for me to recap because I'm just not 100% exactly what's going on. So but anyway, this is in the main game class, which is part of the client. So separated out, as I've mentioned before, we have got like engine and client code. So the source folder here is the client code, and what we did in the last class, or the last chapter that I followed along with, was added a player object. So separated out a bunch of the logic into a player class, which is basically just derived from game objects. So if I go over here, you can see if I go to player, actually, if I go to the definition, yeah, it extends game objects. So again, I'm sort of like tying this into how I think of Unity and game objects in the world with the transform and components, and that's kind of how this whole engine is being built as well. So, but this is fairly straightforward. I mean, we've got like add component, camera component that we saw before. This has just been extracted out into this class, setting the position of the player. In fact, what I'll just do quickly is I'll undo the change I did before, which was this the fall height there of the box. I just do want to keep it the same as what we've got in the classes. I set this to 40 before, or 20 or whatever, just so that you could see the box falling and interacting. So these really are the big differences here. This player controller component. So before it was just floating around the world, and WASD moved the camera around. It wasn't really a player affected by gravity. Now we've got a capsule collider, we've got physics, we've got a rigid body. So let's see if I can semi-piece together kind of the flow of things here and what's going on. So player character controller, just extends the component that can be added to the game object. So you can see here, I've got like this add component as you kind of do, or you could do via code in Unity, or you could just drag it onto the game object within the editor. We've also got a reference down here to the kinematic character controller, which I'll look at in a moment. This is something that isn't part of bullet physics, but encapsulates bullet physics, or is a wrapper. So I don't think I mentioned that at the beginning of the video. We've basically added bullet physics within this project. So it's not a physics system built from scratch through the class, but if I go to engine and do third party, there, bullet 3.3-3.25. Bullet's fairly widely used from what I've heard. I've not dug much into it, but it's fairly robust. It's been battle tested. It's used in quite a few games, and yeah, so I'm glad we're using it here because I'd not had any exposure to it before really. So let's look in the play component, play controller component. Anyway, I think we're getting the kinematic controller, creating one and then passing the values for the. I think this is the. I think this is the radius and the height. These two values here. But let's take a look at update anyway. This is basically moving the character around based on the delta of the mouse, both on the X and the Y. So again, sort of FPS controls. And then we're setting the rotation finally here as well. And I think at the bottom, we've got, so this is all rotation if the mouse position changed. And then down here, we're calculating sort of the WASD, forward, backwards, and strafe. So there you go, is key pressed, AD, WS, and then space for jump. And then finally at the bottom here, we're doing owner set position. So this owner part here is the game object itself, as far as I'm aware. Yeah, so there you go. It's a pointer to a game object, and then we're setting the position of that game object. What we're also doing here, as you can see, we've got this not on the rotation part of it, but on the movement, the forward, backwards, left, right. We're affecting the kinematic controller as well. So this is because it ties into the physics world, the physics engine, bullet. It's not on the rotation because rotation doesn't affect physics. It's just a camera swiveling up and down and side to side. So, but this was kind of interesting for me of how this ties into the game object as well. So if I go to it's this comment here that I wrote in to sort of kind of solidify, and I know I'm going ahead of myself a little here, maybe you're not following along exactly, but I finally set the scene object position with kinematic controller position. So what we're doing here is basically we're updating the kinematic controller position first, because that's how that's the data that's sent to the physics system that the physics system then drives its calculations off. So if we press forward, for example, on the W key up here, where is it? There, W. We're moving forward, and then normalizing that, and then we're sending kinematic controller walk. So this function here, we're giving the new data of the position that we are now at, or the movement speed that we've applied, and the physics system can then say, okay, let's move this objects forward in the world, and then but we're also sending that back to the game object itself because we want the visual part of that to connect up with the actual physics system as well. So that's why I sort of laid that comment in there as well. I think if I go to the kinematic controller here, so again, this is part of the player controller. I think player controller, or player controller component.h. We've got the kinematic character controller there, and again, this is sort of a wrapper for the bullet physics class. So anything that's sort of like BT there is bullet. This ghost here, I think I'm not exactly sure what this ghost refers to. This is kind of where I got a little bit kind of lost as I was going along. I think maybe the ghost is the part of the physics calculation. It's basically the object that's within bullet physics, which keeps sort of a reference of the position of this object. So it's not directly impacting the player component, but it's got its own object of reference and then update, and then we use that to calculate positions. I think I could be completely wrong on that, so please, anybody, if you are more knowledgeable of bullet physics than I am, do let me know. Let's take a look at walk there. I think that was one that was just called before. So if I go down to player component again and yeah, walk. If I go to there, is it definition? I think it is. Yeah, let's just get this one over here a little bit, and I'll go over there. No, that was wrong. Okay. So M controller. I think this is the bullet physics controller. We did see it just a moment ago, I think. M controller. Yeah, there we go. So bullet physics, or BT kinematic character controller. So this is part of the bullet library, and then we're calling that function within that library walk, set what direction, and that's what we've passed in before from our player controller over here. So based on the keyboard input, in this case W, and I think move plus equals front. Okay, calculate forwards and right vectors. Yeah, so that's the value of forward that we're then adding to move, and then move is getting passed into that kinematic character controller .walk, which is over here, and then that's passed to the physics system. And like I said before, once this is passed into the physics system, it updates and says, hey, this is the new value of where this object is now in the world based on the values that we've passed in. But we're also tying that back to, again, just to repeat myself, the position of the actual game object. So this is owner, which is, again, the game object, and then we're setting position based on what the kinematic character controller position is. So let's dig into here a little bit as well, because I have kind of skimmed over these a little bit, and as I say, I'm following along with this course and writing it out, typing everything as I'm going, but not diving deep into every single line as I'm going. It's more like you can see me now sort of passingly understanding what's going on. Yeah, so kinematic character control is at the beginning of the video, the radius and the float, as I mentioned there. And I think this is where it gets added to the physics world. So yeah, get world. Oh, we've got a physics manager as well. So if I go to that one, get world, go to definition, return M world, and M world is a, let me go find that definition. Oh, there you can see it's popped up. So it's a discrete dynamics world. So this is, again, is part of bullet physics. So world is the physics world, is the way that I'm kind of thinking of it. So the capsule is a new BT capsule shape. So there you go. Again, this is not something that's built from this course. This is part of the bullet physics library. Caching ghost object. You see, I'm not sure what this is exactly. I don't know what that means. I'll have to maybe do a little bit of digging of this. But here we set the position. Yeah, setting world position, collision shape as well, because the system needs to know, what kind of collider it has. Step height as well, because we're using a capsule collider, and that's pretty common in games for characters, so they can walk up steps smoothly. Max slope, and then add collision object, add the collision object to the physics world. So I think this is where you're pretty much adding it in there. So M ghost, yeah, that's the what do you call it, the smart pointer to get, yeah, the smart pointer to get the actual pointer, and then collider with most things, world action M controller.get. So this is where we're kind of adding it to the physics system. So we're setting up all of the fields, all of the attributes that this physics object has, and then finally adding it to the physics system. Gets removed when the kinematic character controller is destroyed, which is when the player controller component is destroyed. Pretty kind of standard stuff here, getting position, rotation, and then, as we saw before, based on the input, we can apply walk. The controller itself, what type is that? Oh, the BT kinematic controller. There we go. So if I go to that definition again, there we go. So ghost and controller. I'm not sure what the difference here is exactly. So again, something that I'll have to dig into a little bit more myself as I go, just to get a better understanding. Because I am skimming. It's taken a while to get through this course because I've got sort of limited time. Here we do kind of like a standard thing within games as well, where we're checking if something is on the ground or not. And again, this is something we've not coded along with this course. We're not checking if the distance of the bottom of the capsule collider is below the floor or anything like that. We're just asking the physics system, say, hey, are we on the ground? If so, we can jump. So that's kind of the player character component. So that's as I mentioned at the beginning there, we've kind of got this player character player controller component. From there, it's got the kinematic character controller, and that kinematic character controller itself, if I go over here, has the references to the bullet system library objects. The other thing that we've got as well, as you saw in the video at the beginning, is the box, and that's the rigid body stuff over here. So if I just go step back a little bit and show you where that's instantiated. So we've basically got the create the box game object, adding a component that you've seen before, like the mesh component with material and the mesh, the position that we're setting it to, so the actual world position, and then here's sort of the new thing as well. So box collider, I think I've got I'll show you that in a moment, the collider class. Box body is in the rigid body, and that's where we're passing the box collider. So I think, rigid body, I've also got it there as well. And then we're adding the components of the box object add component, the new physics component. The physics component is a new one as well, isn't it? So the physics component is how you tie the rigid body to the game object. If I go to rigid body here, actually let's go to collider first. Sorry, I'm sort of dotting all over the place. Again, this isn't a tutorial series. I know I've said that. It's just sort of me talking along and trying to understand things as I'm going. But the collider class here, so this is it's not a component. So it's not something that you would attach to a game object. You would attach a physics component that has a rigid body, and the rigid body also has a collider, I think. So in this case, we have a box collider, and then we pass in the extents, that is basically the size of the collider. So I think I did it here. Yeah, half extents, and then there you go, BT box shape. So BT again, bullet physics. So that is us using the bullet physics library and then passing in this physics object into that physics system so that it can calculate, where things are supposed to resolve. If something collides, what's the resolution of that? If something falls and hits the floor, how's it supposed to roll, etc., etc. Let's step back a little bit again. So I am trying to keep this kind of in a linear, correct sort of talk along, look through, and not dart too much over the place. I'm just trying to understand kind of a little bit more here of, so box collider is the collider class that we just got. The rigid body, which we're calling box body here. So the physics component is something that would sit on the game object. So you can see we've got box object, which is a game object, as you can see there, create object, and then we're adding a physics component to that box object, and the physics component itself looks like it contains the rigid body, which gets passed in the box collider. So if I go to this physics component here, I think I might not have opened that yet, so let me take a look. Go to definition. There you go. So that, physics component accepts a rigid body, and the rigid body is what accepts a collider as one of its arguments in the constructor. But we're calling initialize on this physics component. Get in the world. Okay. So position M owner. Again, this is the game object. So this is kind of how can I put it, the way that I want to understand how game engines work, and part of the reason why I'm doing this course and I'm enjoying it is kind of seeing these things like mowner. So this is a game object, okay? There you go. So it's pointed to a game object, and this component system as well. So the I believe you would describe this as ECS, entity component system. So we've got game objects in a scene, in a world. Those game objects have components, and then this component class up here, wherever it was, I might not have opened it. It is exposing the game object parent, where you can get all of the different, like say world position, rotation, and so on and so forth. The rigid body that was passed in again, so the rigid body is getting that initial position so that it can then allow the physics system to calculate, okay, here's the initial position, here's the rotation, etc., etc. So if I just go to this, in fact, I might as well, since I'm here. And again, apologies for sort of jumping all over the place, but it's half making sense to me as I'm going through this, so that's why it's not very well laid out. But setting only works before object is added to the world, because the physics system will overwrite it with each physics step. Yes, so that makes sense, because it's like again, tying this to Unity, if you try and move a rigid body object, a game object, while it's falling through space, it'll start flickering. If you start actually changing the position of it, each frame fixed time step, the physics system will set it to what the position is meant to be, and you get flickering all over the place. At least I think that's what I've seen for a while ago. I've not done that. I've not tried that in a while. Get world transform position, body set one transform position. Yeah, again, so if there's no rigid body, then return. I thought there was kind of a check here. I think I didn't know if there's a check if it's added to world or not. There is an is added to world field boolean which says, hey, if it's added to world, don't do something, don't change its position. Might not be in there, might be somewhere else. But okay, that's fair enough anyway. The other thing that I did kind of want to there you go, is added to world. Return is added to world. I wonder if I can find a... Is it that one? Nope. I'm sure there was like a way to check if... I'm sure there was a line where it was checking, hey, is it added to world, therefore don't do something. I'll have to find it at a different time. The other thing that I did want to kind of show briefly as well was the physics manager. So this was where we're kind of pumping the physics step. So we create an instance of the physics manager, which is part of like the main engine class. We do a bunch of, this I don't really understand, to be honest. Like this is all bullet physics, like initialization stuff, board phase, collision config, dispatcher, solver, world. So it's all of the different objects and systems that are needed in order to create a physics world. And then we're also setting the gravity down there. So basically the initialization of the bullet's physics system. And again, I don't know exactly what all these do, but yeah, I do need to do a little bit more of a dig. But the one thing that I wanted to show was this kind of world step simulation. There we go. So this is kind of where the pumping of the physics system happens. So the set simulation, I think this is within BT discrete, within the bullet physics library itself. And then we're also passing in the time step that we want to update the system at, so that it knows, how can I put this? It's like a delta time. Well, a fixed time. It's not like a delta time. I think I'm getting a little bit mixed up there. I did do this in my previous C++ project, where I was basically doing a deterministic physics system. So by passing in the fixed time step, if the frame rate was ever laggy, then it would simulate multiple times to keep the physics up to date, and so you wouldn't have collision tunneling. Now, I don't think this is what is happening here exactly, because you could have a very, very low frame rate, but it looks like we're not making up for that here. Update is only called once every frame, and this isn't repeated if the frame rate is very low. I'm kind of trailing off here, but what the thing that I learned in my previous project through this channel was, again, deterministic physics, and there was a great article, I think it was Fix Your Time Step. I can't remember the site exactly, but the very basics of it was, again, having a deterministic physics system requires you to make sure that the physics system is updated even if the frame rate is very low. So let's say the frame rate was at just extremely low, like 1 FPS, whatever. What you get if you didn't have a deterministic physics system, or you didn't have a physics system that was affected by frame rate, then you'd have collision tunneling, for example, where projectiles would just go through walls, players would go through walls, and so on. What the Fix the Time Step article went over was basically, okay, you've got a low frame rate, it's below the fixed time step, as in you can't execute it this fast, therefore we will re-simulate that physics loop. So even if the frame rate was extremely low, and there's a video of it, if you go back a couple of them, it was on my, oh boy, I think it was called Vector Out, my little game that I put on itch. It shows kind of how that works. So I simulated a very, very low frame rate, but the ball was still physically correct. It wasn't going through walls, it wasn't going through blocks, and it was all reacting correctly. So maybe that'll be implemented at some point or down the line. Let's see. But there, more kind of Unity related stuff, but this is where we're adding the rigid body to the physics world. So this is the physics manager, which is the kind of singleton class which handles, okay, here's all the rigid bodies that got added to the world, here's where we're updating the physics step. MWorld add rigid body again, so this is part of the bullet physics system. Setting the filters, the actual rigid body itself, body set added to world, true, there we go, so we can't affect it afterwards. Again, if it's already been added to the world, then we can't affect its position. We'd have to remove it from the world, which we've got down here, and then we could update it as, like, say, a kinematic object, or set its position by code to put it wherever we want, and the physics system wouldn't affect it. Then you could re-add it again if you wanted, and then it would be affected by physics. So that might be something like if you wanted to pick up objects, so I'm thinking of Portal in my head, where the cube drops on the floor, you pick it up, and it just moves around as like a kinematic object. It's still affected by static objects like the walls, but it's not being driven by the physics system as a dynamic object. So that, again, that just me saying that right now is making the way that physics works in other engines more clear to me. And again, specifically kind of Unity, because I primarily work with Unity. That, even though that's a different physics library, I think it's PhysX, I could be wrong on that, but that kind of makes sense to me. Like, okay, the physics is driving it, every fixed time step. If you want to affect it, you have to take it out of that physics system temporarily, or disable it temporarily, and then re-add it after you've done messing with it, with like the box example I made with Portal. So all of these little neurons firing as I'm kind of talking through and just looking through this code is kind of helping me understand how Unity works under the hood, and how game engines in general sort of work under the hood. So this is why I'm doing this, and this is why I'm sharing, and I'm finding it useful to go through these examples here. But I think that's about it. I think that's all I wanted to cover. Like I say, I can't go through everything, and I won't, because again, it's a paid course on Udemy. The link is in the description if you're interested. Check it out. Again, it is a referral link, so I do get some small percentage from Udemy if you refer it, if you do buy it. But yeah, it's I would recommend it anyway. It just helps support the channel and lets me do more of these videos. So, but yeah, it's getting there. I mean, this is first you know, this is FPS. It's very laggy because this machine is terrible. I'm working on right now, this laptop. But that is starting to look much more like an FPS, and I've got animation there. No bullets coming out at the moment, but yeah, it's coming together. So stay tuned for the next video, guys. I'll see you later.